Thank you, Mark. So in every GEC, we try to showcase either what people are doing with GENI, interesting new experiments, or showcase the new capabilities in GENI. And for those of you that were in GEC17, probably you remember me trying to do a complete demo. And I did it a little bit fast, if you remember. It was like a race. So this time I decided I won't be the one doing it. So last time we used the Gemini instrument INM tool, and we used the proto-GENI resources. This time we're going to see the new labwiki that is integrated INM tool with GIMI, and we're going to use the ExoGENI racks to do that. And Mike Zink from UMass Amherst and Shufeng and Divya are going to join and do the demo for you, so that you actually get a chance to see it this time.
So good morning, everyone. Welcome. It's nice to be here in Madison. It's a really nice place. Why did you guys come up and set up your stuff? I think that makes it a little easier. What Niky forgot to mention is I'm from Germany, so driving things fast. I'm not good at going slow. So be careful what you're asking for. Let me just set this up here. Get started. So I'm Mike Zink from the University of Massachusetts in Amherst. I have with me here on stage Huang from University of Kentucky, and Divya Bhat, who is one of my grad students at UMass. And we're going to show you a kind of complete experiment in GENI by using GIMI tools, especially labwiki. And I just want to show you why there are so many people up here this morning. I just want to give you a quick introduction, and then they will show you their experiment. And I think this is much greater to have the students actually showing how they run experiments, to present their own work and not the professors messing it up. And then I'll spend another 5 minutes, if we have time, just to show you what's new coming up with our tools, kind of new features, just really prototypey, but they will hopefully get into the production stage pretty soon. Let me just use this microphone. This is a little easier. Is this working? Working? Yeah. Yep. So, we have heard this today a couple times. We want to make the usage of the resources that are coming up in GENI a lot easier. Because, as a researcher, the fun part is actually thinking about it, and, in the morning in the shower or at night before I go to bed, come up with a great idea. And then actually, spend as little time as possible and actually kind of, maybe proving my hypothesis and then writing up something nice and publishing it, right? This is kind of the thing. And so we want to make this process in the middle as short, as convenient as possible. That's not easy. That takes a lot of time. And we would like to also have your input on that. So, if the folks who went to the tutorials have seen that many times, the design of the setup, the execute of the setup, and the finish. But that's usually, how many times do you do this? Do you do this one time? Who does it one time and publishes a paper? Everyone who raises their hand is lying, right? So do you do this 10 times? Do you do it 100 times, right? You do it many, many, many times, And so that's actually how we think about the experiment cycle, right? You design an experiment, you set it up, you execute. And you go and go and go and over and again until you get your results and have the things in the way you like it. So, my definition of a successful experiment cycle is then actually doing many, many, many times and you publish something. Or you publish a few papers, have a good idea, write a new grant and get it funded. That's super successful, right? So that's kind of the idea. So you're going through this cycle, but you want to use tools that make it easy to go to the cycle. Also, when you go through the cycles many times, you want to be able to kind of keep notes, keep track of the things you're doing. If a person like me is getting older, forgetting more things, has like 1,000 things going on over the day, grad students running in your door and all this kind of things, it's good to be able to take notes and go back and look at them, right? Or what did I do last Monday? Why is this result there, right? And so that's kind of the thinking here we're doing is kind of with a tool we call labwiki that allows you to kind of organize your experiment in a better way. So this is kind of this one place you go to. When you look on your side, on the left-hand side, you have a real wiki in there where you can take notes, where you can store information, where you can store results of your experiment. It's like the good old lab book. I go back and tell these guys here, in the old days you had a lab book and you were writing things down. I think a lot of people losing that skill. right? It's really important, I believe, that you still take notes, because sometimes just going through the process of your research helps you to get new insights. And so that's what can you do there. Here the good thing is it's electronically, so you cannot lose your lab book, right? You know, it's probably happened to all of us before. So that's an important part. You can design your experiments. In the middle is about preparation. You can write experiment scripts. You can specify how you run your experiment, and then you can execute your experiments. So with respect to time, I don't want to spend too much time, and I want to have them show their cool demo here. I want to also say labwiki is designed in a way, you know, with kind of plugins, and you can create your own plugins. So if you don't like the experiment scripts we have right now, you think that's too complicated, you want to do something else yourself, you can come up with an own plugin. And we have done a lot of work in kind of, you know, integrating this into the overall GENI architecture, working with tools, working with resources. You can now go through OpenID with your single sign-on. You know, you just use your ID through in common, log into the tool, have everything there, and so it's not perfectly integrated, but it's nicely integrated. It uses iRods to store your data, and so we're getting more and more into kind of this, you know, making it easier, smoother to run your experiments. And with that, you know, I just would like to hand over to these two to show their demo.
Good morning, everyone. In this demo, we are going to show you how to design and monitor open-flow load balancing experiments using GIMI. It's a combined work between me, while I was doing my intern at GPO, and Divya from UMass, who's been helping a lot to make it happen. So while we were thinking about doing this demo, we want to create a topology that is as simple as possible. And also, we want to be able to redo our experiments easily. And we also want to be able to monitor our experiments to display them in a live graph, something. So to reach our goal, here is the simple topology that we created. In this topology, we have one sender and one receiver at the bottom. And there are two paths between the sender and the receiver. And there are two open flow switches. One is the load balancer, which is close to the sender, and the other is the aggregator, which simply follows the path decisions made by the load balancer. So for this demo, we are going to mainly focus on the load balancer. Some of the keywords that is covered in our demo, we are going to reserve exogeny resources to build our topology, and we are going to use OVS as our open-flow switches. And for running the load balancer, we are going to use Trauma platform, and we are going to use GIMI or labwiki to monitor our experiments. So here is the design of our experiment. We start by sending out several TCP flows from the sender to receiver without enabling the load balancer. In this case, the switch near the sender will simply pick the default path, in this case the left path, to forward every traffic to the receiver. In step 2, we are going to enable the load balancer on the load balancing switch. And then we are going to send more TCP flows from the sender to the receiver. In this case, since the load balancing is enabled, we're going to see traffic that being forwarded to both the left and right paths. And as I mentioned earlier, we also want to monitor our experiments. In this case, we are going to monitor the two interfaces on the load balancer, corresponds to left and right paths. So when we start TCP flows from the sender to the receiver initially, we are expected to see that all the traffic are sent out through only one of the paths. As we enable our load balancer and send more TCP flows from the sender to receiver, we are expected to see that traffic also coming out from the right path. So how do we map our design onto GIMI? It's actually very simple, about 10 lines of Ruby code. Step 1, as you can see here, we start 2 TCP flows from the sender to the receiver using iPerf. And then we waited for about 20 seconds to make sure that we see the graph that traffic only comes out from one path. Step 2, we are using Tremor to run our load balancer controller. Just one line code. In step 3, we are creating 10 more TCP flows from the sender to receiver with the load balancer enabled. And we also mentioned that we want to plot a live graph. So here is the 2 live graphs we want to plot. On the left side is the total number of bytes we've seen from the left and right paths. And the right graph shows you the TCP throughput that we observed on both paths. And the top simply shows you how do we do that in labwiki. Let's go to our demo. So as we all know, the first step is to reserve resources. In our case, we have already reserved our slices. And you need to log on to labwiki first, as we have already logged on to it. And then we load our labwiki script, as I described earlier in the slides. Then we drag and drop the icon to execute the column and give our experiment a name. Experiment GEC17 demo, and name the slice of our topology, slice name of our topology. It has to match with the slice name. And we type true in the graph column, just ask it to display live graph. Then we click start the execution. As you can see from the logs of labwiki, it shows you on which stage are we is our experiment on. And it's already started. And we can see the live graphs being plotted at the bottom. And one nice feature about labwiki is that you can actually drag and drop the live graph from one column to the other. And as you can see here, before time 20 seconds, all the traffic are going out to one of the interface, one of the paths. In this case, it's the left path. And after about 25 or 28 seconds, we can see that packets are being forwarded to both paths. In this case, we're using a very simple load balancer, which load balances the flow in a round-robin fashion. So in this case, if the TCP flows come in a way that all the odd number of TCP flows uses less bandwidth, and all the even number of TCP flows uses more bandwidth, then the result is that this round-robin load balancer will put all the small TCP flows onto the left path and all the big TCP flows to the right path. The result is obvious, as you can see from the graph. It's not load balanced well. It's all right. It happens that we have another load balancer which does the load balancing smart. So what we're going to do is redo our experiment. We change our GIMI script slightly to use the more smarter load balancer and redo our experiment. So in this new smarter load balancer, we are going to do the load balancing based on the total number of traffic we observed from each of the paths, so that it actually pulls the statistics. You can go ahead. Statistics about the number of bytes sent out to each path once every 5 seconds. So the OpenFlow controller's knowledge about the networking is up to date. And then based on that information, it load balances the flow. And as everybody knows, or open flow controller controls traffic based on flow. So it's really, really hard to load balance traffic perfectly. But as you can see from the graph, it's doing, this version of load balancer is doing much better than the round-robin load balancer. And there's another nice feature about labwiki is that you can actually save the plotting results from your last experiment on the same page so that you can actually compare the graphs of your 2 experiments or more experiments. As you can see, these 2 lines, as the load balancer kicks in, these 2 total number of bytes lines, it's kind of parallel, and it's doing much better than the round-robin load balancer. So I hope we have demonstrated how simple it is to redo experiments on labwiki. And let's go back to the slides. So to sum up, these are the steps that we have went through. We first reserved load balancing topology from GENI. Then we instrument labwiki to run our experiment. The labwiki controls all the nodes that we reserved to send monitoring results to the OMF server, which in turn plots the live graph onto labwiki, as well as it saves all the monitoring data to an IROD server from where the user can obtain the detailed logs. And it seems to be a very complicated process, but the good news is most of the steps are already automated for you by labwiki, so that the user can focus more on the design of its own experiments. And if you guys want to know more about what we have done today, or even try out more load balancers, we have a tutorial in this afternoon at 1:30, where you can redo whatever we have done here today. And if you are interested in more advanced features of labwiki or GIMI, or you want to explore how to do experiments with WiMAX using GIMI, you're also welcome to other tutorials this afternoon and tomorrow morning. And that's it. Thanks.
Isn't that nice when your students have a successful demo? Thank you very much, guys. So I wanna spend a couple more minutes, 5 more minutes, and then you all get your coffee. I need mine too. I understand that, and just show you a couple of things that are coming up. So you've hopefully gotten an idea what you can do with labwiki. Let me mention one thing, which I want to highlight here. What Shufeng and Divya showed you in the end is actually that we can run closed loop experiments, right? What you've seen in the last part is actually we measure and then change the open flow controller, right? So we can actually change our experiment based on what we observe. That's not sometimes what we want, but sometimes that might be really interesting, right? So you see something and you can run then really long-term experiments based on that. And keep that in mind when you're designing your own experiments. So don't look at the Latin skills here to the left. That's just a little mock-up here to show you some of the new features. One of them is actually that we have links now in labwiki. So on your wiki part, you can actually put in a URL to an experiment script, right? So we're thinking about this, and I think this becomes more and more important in our world of creating test beds and running experiments, and how do we publish about these experiments? And all of you have seen our good friend Max Ott standing here and talking about this kind of idea also helping with publications. So you can actually put a script out where you put your link in, and then someone else can use that to reproduce this experiment, right? And with GENI, we want to do reproducible experiments. So we can share our links via URLs. Here's a URL, the experiment script pops up, and we can use it and run an experiment. So that's one of the new features we're having here. The other one we're working on right now is actually being able to create topologies in here in labwiki itself. So before we have to use other tools to create the topologies, but now we are working on a topology generator, so you can create your own RSpec for a topology, for example, in labwiki, and create that topology and save it, and then use that for your experiment preparation. And then the final thing, what you see is blinking here on the right-hand side already. This is not based on any data coming back, but we just have created an image that you can bring up on your testbed racks, and that image automatically, based on the topology, checks if the links and the nodes are alive periodically, sends that information back in the measurement database, and then displays it. So what you see here is actually when it goes red, that would be the case where you have a problem. So what is good about that is when you run your experiment, you'll be notified about any problems that are not part of your experiment, right? Links go down, machines reboot. We have all seen that before. Slices go away, right? I don't want to mention that, but that's a good thing, because you've been working in this, you've been preparing your experiment. It's finally 1 o'clock in the morning. You want to go to sleep, and then you wake up the next morning, everything is gone. And what happened, right? So if you have a tool to observe that, monitor that, right then in the database, can search your database for that going on. We all thought that was a very helpful tool. So with that. Are we taking questions here or not? If there are any questions, I'd be happy to take any questions. Before I take questions, I also want to say, this time, thank you for trusting us and GPO and putting us up here for the demo. Feel very honored about that. Thank you for also supporting us in all our efforts. I want to thank all the people involved in this. It was a great, collaboration. First of all, with the GPO. What you haven't seen here is actually going through the portal and logging in. So this is kind of a one-stop thing you can do right now. Between our friends at Niky, Shufeng and Divya and Huang, who have been at BBN as interns this year. A lot of people involved in this. Thank you all for your hard work, staying up at night and working on this. Jack actually was on a 16-hour flight from Australia, something like this, right? So he's out of his mind by now. And so thank you all for doing this. Be happy to take any questions.
So it's time for a break. We'll take half an hour or so, and we will regroup back here to see a demonstration and a technical deep dive into GENI stitching. Thanks very much.